Hello, good morning, students. How are you? Fine? Okay, I am also fine. In the last class, we have seen governing of turbines using spare gear or deflectors or using both spare gear and deflectors either in impulse turbine or reaction turbine, that is Francis turbine or Kaplan turbines. Today in this class we will see or we will understand comparison of turbines and selection of turbines. Okay? Comparison of turbines. Criteria: Pelton turbine, Francis turbine, Kaplan turbine. With respect to type, Pelton turbine is an impulse type water turbine, whereas Francis turbine is an inward flow reaction turbine. Kaplan turbine is a propeller type reaction turbine. With respect to head criteria, it is used for high heads. It is used for high heads ranging from 250 to 1000 meter. Francis turbine, the operating water head of a Francis turbine ranges from 40 to 400 meter, whereas Kaplan turbine is very low head, 10 to 70 meters. Criteria number 3: direction of flow of water through the blades. In case of Pelton turbine, the flow of water is tangential to the runner, hence it is also called as tangential flow impulse turbine. Francis turbine, with respect to this criteria, the flow of water through the blades combines both radial and axial flow, mixed flow turbine. Whereas Kaplan turbine, the flow of water is axial through the blades. That's why they are known as axial flow turbine. Pelton wheel is tangential flow turbine. Francis turbine is mixed flow turbine. Kaplan turbine is axial flow turbine. Fourth criteria: discharge required. The discharge is very low as head is high and the direction of flow is tangential. The required discharge is low. It is medium here. Here it is very high because head is very low at the tune of 10 meters. Fifth criteria: type of energy. The Pelton turbines uses kinetic energy and converts into mechanical energy, whereas Francis turbine converts potential and kinetic energy into mechanical energy, whereas Kaplan turbine uses both kinetic and potential energy, which then is converted into mechanical energy. Sixth criteria: efficiency. The efficiency of a Pelton wheel turbine is about 85%. Francis 90%. Kaplan is also 90%. Seventh criteria: runner speed in RPM. 750 to 1000 in case of Pelton wheel, 94 to 1000 in case of Francis, 70 to 600 only in case of Kaplan. Blades, with respect to blade criteria: double hemispherical fixed on wheel. You have seen just like a two house. Radial vane fixed on runner. This is fixed on wheel. This is fixed on runner. This is adjustable. However we want, we can adjust it. That is the difference, comparison among these three turbines. Last criteria perhaps: specific speed. Pelton turbine very low, 8.5 to 43, whereas Francis turbine is 50 to 340, whereas Kaplan turbine is 255 to 860 RPM specific speed. Okay, this is how comparison is being done. I said last, perhaps it is last criteria. 9 criteria are there. In exam, it can be asked for 4 marks. At least out of 9, you remember any 4 criteria, you will get full 4 marks. Okay, very simple. Just you have to study and remember the things. Now, selection of turbine. Selection of turbine. It's enough, it is visible. The following points should be considered while selecting the right type of hydraulic turbines for hydroelectric power plant. Specific speed. High specific speed is essential where the head is low and output is large, because otherwise the rational speed will be low. Rotational speed will be low, which means cost of turbo generator and powerhouse will be high. On the other hand, there is practically no need of choosing a high value of specific speed for high installations, because even with low specific speed, high rotational speed can be attained with medium capacity plants. Selection of turbine based on specific speed, just now we have said Pelton wheel 8.5 to 30, Francis 50 to 340 and Kaplan 255 to 860. In this case only single jet, double jet in case of Pelton wheel or impulse turbine. If double jet is there, up to 43. Based on rotational speed, selection of turbine. Rotational speed depends upon specific speed. Also, the rotational speed of an electrical generator with which the turbine is to be directly coupled depends on the frequency and number of pair of poles. The value of specific speed adopted should be such that it will give the synchronous speed of the generator. Third factor for selection of turbine efficiency. The efficiency selected should be such that it gives the highest overall efficiency of various conditions. Fourth, part load operation. In general, the efficiency at part loads and overloads is less than that with rated or design parameters. For the sake of economy, the turbine should always run with maximum possible efficiency to get more revenue. Always we should think in terms of revenue. Whatever we are spending for the establishment and development of such plants, we should also expect, that means government should also expect some revenue. For that purpose, for the sake of economy, the turbine should always run with maximum possible efficiency. Pelton wheel is preferable operation in comparison to Francis turbine, though the former involves higher initial cost. Of course, impulse turbine is costlier than Francis, but still comparison with Francis, it is preferable. For heads below 30 meter, Kaplan turbine is preferable for part load operation in comparison to propeller turbine. These are the different curves shown. You yourself can understand. All the parameters are also shown in this figure. Okay. You yourself zoom it and you can see the different curves, percentage of load and efficiency in percentage on y-axis. We'll come back. We'll come back soon. I'm adjusting just by zooming. Whenever I am sliding my finger, the figure should not move to and fro or up and down. Now it cannot move. So anyway, x-axis data is invisible, that is percentage of load, efficiency, and y-axis in percentage efficiency. These are the different curves. Kaplan turbine, NS is 600 specific speed, Pelton wheel 13 specific speed, Francis 300, and propeller turbine NS 515, 515, 1, 2, 3, 4. One is Kaplan turbine topmost, second one is impulse turbine Pelton wheel, third one reaction turbine Francis, this is propeller turbine. The efficiency percentage load curve is shown here. So how you will understand this? How you will read the graph? You see, as the percentage of load increases, efficiency also increases moderately in these two cases. Whereas in the former two cases, that is Kaplan turbine and Pelton wheel, there is sudden increase in the efficiency. That's why Pelton wheel is preferable than Francis turbine. With respect to this statement, this is true. TRUE, true. Okay. Fifth factor for selection of turbine, available head and its fluctuations. Available head and its fluctuation. Very high 350 meter and above. For heads greater than 350 meter, Pelton turbine is generally employed and practically there is no choice except in very special cases. No choice. Only Pelton turbine, impulse type turbine. When the high head is more than 350 meter. High heads 150 to 350. Less than 350 but more than 150. In this range, either Pelton wheel or Francis turbine may be employed. For higher specific speed, Francis turbine is more compact and economical than the Pelton turbine that for the same working conditions would have to be much bigger and rather cumbersome. Medium heads means less than 150, more than 60. A Francis turbine is usually employed in this range. Whether a high or low specific speed would be used depends on the selection of the speed. So could you get more than 350 meter means impulse turbine is the only alternative. If it is less than 150 and 60 meter in between, Francis turbine is the ultimate use. No other choice. Whereas in between 150 350 meter, in this range, either Pelton wheel or Francis turbine can be used economically. Right? Next. Another point. Available head and its fluctuation is continued. Low heads, that is below 60 meter, between 30 meter to 60 meter, both Kaplan and Francis turbines may be used. This is how selection of turbine should be made judicially by the engineer in charge. Kaplan turbine is generally employed for less than 30 meter. Propeller turbines are however commonly used for heads up to 15 meter. They are adopted only when there is practically no load variation. No load variation. Variation should not be there. In that case, the propeller turbines are commonly used. Otherwise, up to 30 meter, Kaplan turbine is used. Deposition of turbine shaft. It should be disposition होना चाहिए. Disposition. Experience has shown that the vertical shaft arrangement is better for large sized reaction turbines. Better for large sized reaction turbines. Therefore, it is almost universally adopted, whereas in case of large size impulse turbines, horizontal shaft arrangement is preferable. Could you understand this statement? Experience has shown that vertical shaft arrangement is better for large sized reaction turbines, that is Francis. Therefore, it is almost universally adopted. Whereas in case of large size impulse turbine, that is Pelton wheel, always the horizontal arrangement is preferable. That's why this word should have been disposition, not deposition. Disposition. Disposition. Okay. Thank you very much. One more class is left. I forgotten to say, in the last class I said one more last class, but one more class is there in this article. Okay, we will take in the next class. Thank you very much for patient hearing. Have a good day. Have a good day.